Hello, today I want to take a look at the method of dimensional analysis in order to make conversions in the metric system. Now, this particular method is going to be useful for all the conversions that we are going to be looking at in this chapter. So let's take a look at the steps that we can use in order to make our conversions using dimensional analysis. There are three basic steps that you will want to use when using dimensional analysis to make your conversions. The first step is to convert to the basic unit, and we'll take a look at that in an example to see what it looks like. The second step would be to do an additional conversion. Occasionally you may have to move to the basic unit twice in order to make your conversion. And then finally, you're going to simplify your outcome. Okay, so before we take a look at some example problems, let's take a look at what it means to convert to the basic unit and look at some of those conversion factors that we're going to need to use when we're doing dimensional analysis. So let's say that we have this example here where we want to translate kilometers to meter, or it could even be meters to kilometers. It doesn't matter which conversion we're going to want to make, we will need to use the same conversion factor. So let's take a look at where these end up happening in our diagram. So again, a meter is our basic unit here. And so if we're looking at that, remember that that's going to be a 10 to the 0 power. And if I'm looking at kilometers, they're over here, and that's a 10 to the 3rd power. So I want to take a look at those two exponents there, or the other way I can think about looking at this is that you've got the basic unit here, which is increasing by 1 here, 2 here, and 3 here. So basically, I have 3 decimal places that I need to move to get from a meter to a kilometer. So how am I going to set up the relationship? Well, one of the things you're going to want to remember is that when you're looking at the values in the chart, remember that on this end we have small values, on this end we have large values. In fact, as we move from right to left, we have larger quantities that we're working with. And so anytime we're looking at a small quantity, let's say we have a bunch of micrograms, for example, we're going to need a lot of micrograms to make up a single gram, or we're going to need a lot of grams to make up a megagram. You're always going to need more units that are on the right side to make up something that's on the left. And so that's the idea I'm going to use here to look at my conversion factor between my kilometers and my meters. So I know there is an exponent of 3 between them, and if I'm looking at 10 to the 3rd, that's 1,000. But 1,000 watt is going to equal 1 watt. Well, taking that idea again of having to work from the smaller value here to the larger value that's to the left, it's going to take 1,000 meters for me to have 1 kilometer. Now, whether or not I'm converting from kilometers to meters or from meters to kilometers, this would be the conversion factor I would need to use. Now, I don't want you memorizing these. I want you to be able to create them from the diagram that we have up here at the top. So let's take a look at another example. Okay, so let's suppose that I want to convert from centigrams to grams or grams to centigrams. Again, it doesn't matter which one of these two conversions I'm going to want to make. What I want to take a look at is the relationship between these two quantities. So if I'm looking at a centigram, notice that a centigram is right here. I have an exponent of -2. And with the grams, again, that's my basic unit here, just like in the previous example. So the difference between these two is 2 exponents. And so I need to figure out how many of one makes up the other. So again, I want to take a look at if I've got 2 decimal places, that means I'm dealing with 10 to the second, which is 100. So 100 of what will equal 1 of what? So remember, if I'm moving from the right to the left, it takes more of the smaller quantities, which the centigram would be my smaller quantity, to make the basic gram. So I'm moving right to left. So therefore, I would need to have 100 centigrams to equal 1 gram. So that would be how I would do my basic unit conversions, and that's kind of looking at this very first step in the dimensional analysis. Notice that in both of these, I related it back to the basic unit that we were dealing with. So let's take a look at one more example where we can take a look at where we might need to use 2 conversions. Okay, so in this example here, where I'm looking at hectoliters to deciliters, or deciliters to hectoliters, I am actually looking at crossing over this basic unit in the middle, in that I have hectoliters over on the left side of the basic unit and deciliters over on the right side. So this might take 2 conversions because I always try to go back to the basic unit when I'm converting. So I'm going to first take a look at hectoliters and look at how do hectoliters relate to liters. And so we're going to start with that relationship. So if I take a look at my hectoliter, which I'm going to use blue here to differentiate between the other examples we did, and I'm looking at liter, which is right here, I have, again, in terms of exponents, a difference of 2. So I'm looking at 10 squared. So my relationship is 100 of what will equal 1 of what. So again, which one is the smaller unit? Well, the smaller unit is my liter in this particular case. So how many liters will it take to make a hectoliter? It will take 100 liters to make 1 hectoliter. And so this would be my conversion factor to get from hectoliters to liters, but notice it doesn't include the deciliters. So now I want to take a look at, okay, how do my deciliters relate to my liters? What am I going to need to do there? Well, again, I'm looking at my basic unit, and so I'm still going to look at my liter, but now I'm looking over here at the deciliter. What's the difference in exponents? That's right, there's a difference of 1 here. And so even though this one is a -1, the difference between these two is a factor of 10. So now I need to take a look at which is going to go where, basically. So I'm going to need to have 10 of what is going to equal 1 of what. So again, which one's on the right? Deciliters are on the right. That's a smaller quantity. So it will take 10 deciliters to equal 1 liter. And so there is my second conversion factor. Okay, now we're going to take a look at some examples. Okay, so let's take a look at this particular example where we want to convert 0.375 liters into how many milliliters that is. Well, we just took a look at liters and milliliters in the previous slide. So let's start by figuring out what is that basic conversion factor we're going to need in order to make this conversion using dimensional analysis. So remember that my liters is in my basic category here, which is 10 to the 0, and my milliliters is right here, and it has a 10 to the 3rd. So the difference that I have in decimals here is there's 1, 2, 3 decimal places there. So the conversion I'm looking at is a difference of 10 cubed, or 1,000. So I need 1,000 watt to equal 1 watt. Well, again, what's smaller? The milli is smaller than the liter, which is my basic unit. So it is going to take 1,000 milliliters to equal 1 liter. Now I'm going to use this fact that I just created again in order to make the conversion that I'm given here. I'm going to start by taking my 0.375 liters. I'm going to write that over 1, and I'm going to multiply it by my conversion factor. Now I want to change this to milliliters, which means that I want to get rid of this liter that's right here. So in order to get rid of it, I need to have a liter on the bottom. And so that's how I determine how I'm going to set up my ratio that will allow me to make this conversion. So if I want liters on the bottom, then I have 1 liter on the bottom, and I have 1,000 milliliters on top. And now I can take a look at canceling out the liters, and notice that the label I have left is the milliliters, which is what I want. All I need to do is multiply these two values together, and I'll have my answer. So 0.375 times 1,000 is going to be 375. So this is going to, so 0.375 liters is actually 375 milliliters. Let's take a look at another example. Okay, so let's take a look at this example. I have 23,600 centimeters, and I want to change that to decameters. All right, so if we look at this one, you'll notice that centimeters are on this side of the basic unit. Here again is my basic unit, and my decameters are over on this side. So I'm going to need to have two conversion factors. So let's start by looking at the centimeters and seeing how it relates to the basic unit. So notice we have 2 decimal places here that go between the centimeters and the basic unit. So I'm looking at 10 squared, which means that I have 100 of something that equals 1 of the other. So centimeters and meters. Well, centimeters is here on the right side, meters is on the left, so that means that I have 100 centimeters in 1 meter. So we just talked through that, but this might actually be a conversion that you are familiar with. Think of a yardstick, and when we turn it over, we often see a meter stick, and a meter is 100 centimeters. Now, let's take a look at the centimeters, not the centimeters, I'm sorry, the meter and how it is related to the decameter. So you'll notice that there's only one difference in exponents there. So I'm looking at a difference of 10 to the first, which means I have 10 of the one is equal to 1 of the other. So what's that going to be? Well, once again, notice that the basic here is now to the right of the decameter. So that means that I am going to have 10 meters equal 1 decameter. So we now have two conversion factors that we are going to use in this problem. So let's go ahead and make the conversion. So I'm going to start with my 23,600 centimeters over 1. And I'm going to multiply it by, now I want to start by getting rid of the centimeters. And so to get rid of the centimeters here, I want to start with this first conversion factor that I created. So again, I want to look at what needs to go on the bottom. Well, I want to get rid of centimeters, so I'm going to need to have 100 centimeters on the bottom and 1 meter on top. Well, that works out very nice because now I've got the centimeters gone and I'm looking at this in terms of meters. But that's not what we have up here. I need to have decameters. So I need to use the other conversion factor. So I'm going to multiply. Now I'm not going to calculate out those first two fractions. I'm just going to continue on here, and this is where true dimensional analysis comes into play. Now I want to get rid of the meter. So I'm going to look at this second conversion that I have here. I want to get rid of the meter, so that means I'm going to have 10 meters on the bottom, and I'm going to have 1 decameter on top. Now notice again, the meters here will cancel. They're common on top and bottom, and so now I'm left with my decameters, which is what I wanted. So I can go ahead and multiply across the top, which would give me 23,600 divided by, now 100 times 10 is going to give me 1,000. So if I simplify that down, I'm going to get 23.6. And so I can take a look at this and fill in my blank here, and I end up with 23.6 decameters. So this is using dimensional analysis to make these conversions. We will be continuing to use this method as we move into other ways of converting units in this chapter.